Hello, my name is Guadalupe Maldonado Andrade. My internship was at the Everglades National Park. My internship focused on improving a predictive model that determines where archaeological sites would be on Tree Island, specifically within Shark River Slough. So, in addition to a literature review that I worked on towards the beginning of my internship, I was also able to have a lot of professional development opportunities early on. I was able to attend a weekend intensive Python bootcamp. It was led by UC Berkeley, so that gave me some insight on possibilities to use coding for my work. I was also able to attend some of the Esri e-learning courses on modeling techniques. So I began with conducting a literature review, reading into a few things. So I did some reading into archaic sites of the Everglades, which tree islands primarily are a location of the early human presence within the Everglades, as well as the importance of the carbonate layer for archaeological artifacts, and as well as the development of tree islands, which it's really cool. I didn't know too much of the details on this, but as you can see, it works as a feedback cycle. So as tree biomass increases, you have greater litter fall and root production, which then gives you an increase in peat accretion, and then you have tree islands expanding, and then nutrient capture increases, and that feeds back into the cycle. My literature review also looked into landscape changes in the Everglades that have impacted tree islands and peat accretion due to fluctuations in drought and drainage. I also looked into the different vegetation regions of the Everglades, just to see which of these types is very crucial for modeling, which tropical hardwood hammock has been very crucial for past surveys and modeling. The previous model had these focal factors. So they focused on elevation, hydrology, and vegetation data. And in terms of their vegetation data, they did point out that they had some discrepancies in between 10 to 15 meters in terms of the spatial data. And they focused on hardwood hammocks, where 60% of of archaeological sites would occur here, and they stated preferably because it is on higher ground. So we focused on gathering data to develop a model to run along Shark River slough boundary. So given the many changes due to COVID, our project also had some changes, and we focused on an area that would be feasible within our time period. So the main variables that drove our updated model were vegetation data from various sources, as well as elevation data from LiDAR, as well as previous knowledge of existing archaeological sites. So the red points are recorded sites, and the dark green highlights are tree islands, while the lighter green is surrounding vegetation. So before I was able to get a physical laptop and access to NPS data, I started by looking through USGS for any type of data that had the correct, or I guess the most accurate quality compared to the data that we would be working with. So I found that Sentinel data matched up pretty well with the accuracy that we wanted. Um, and so my biggest issue with looking through these different data sets and the specific files was finding something that didn't have too much cloud coverage. Most of the data files appeared to have a very small percent, but once I downloaded them and pulled them up on the software, there were so many clouds and it hindered the analysis. So the clouds would be misclassified as vegetation or as something else, and it would just interfere with the the numbers. So once I found imagery with no clouds, I used the image classification wizard in ArcPro, which is pretty similar to a remote sensing technology in Envy, which is a remote sensing software. So I used a supervised pixel setting, which it it classifies each individual pixel, so it's very, very accurate. And the supervised part of this analysis is that you provided with categories you wanted to classify the pixels in. And the NDVI was done a little differently. It was done unsupervised, so it classified the categories on itself based on the pixel similarities. So running the model, we use a combination of existing GIS layers and the USGS Sentinel layer to test in Maxent. And it was Maxent was a pretty easy tool to get the hang of. So we add our sample population and then our environmental layers to base the model off from. So I mostly teleworked, but I got to spend a week in the Everglades doing field work and running the model last week. So here I have the Maxent raster layer that predicts where we're most likely to see archaeological sites. So the light gray circles encircling some of the high probability areas represent tree islands. So the red is the highest probability, white is no to lowest. Due to the storms and the rain, the areas that we needed to survey for archaeological sites were inaccessible. A lot of the roads leading to the site were completely flooded, so this was actually the closest that we were able to get to our site area. It did give me a really great perspective to drive through and see the very different vegetation composition that makes up the Everglades. So it really pieced together some of the questions I had when I was analyzing the GIS data. So what I worked on during my time with the Everglades National Park is a part of a bigger whole that will be used to determine where archaeological sites are and if they are widespread along the tree islands or not. And so the archaeological site localization is the first step to forming an analysis of the costs and the benefits to restoration to see if this restoration plan is going to affect a large percent of archaeological sites on tree islands or not. We're not really sure in terms of the very specific distribution of where archaeological sites are, but our model will show us the hotspots, and hopefully from there that will be a good starting point. And thank you.